or many products are invented and many products are developed in the society for the usage of the people or to commercialize. Every products are today in the form of miniaturized size. That's what we deal it about micro. And uh, one thing is to easiest way to carry, and one thing easiest way to mobilize, and easiest way to transport, and easiest way to adhere. So these are the things behind why we are going for miniaturized things. And when we go for miniaturized things, certain complications we have, certain challenges we have to the society. Being a mechatronics engineer, you are developing many products with the help of sensors, actuators, comparators, design modules, right? But everything, lot of challenges we have. Thereby, in order to overcome the challenges. In one part, we may speak about the challenges. Other part, we may talk about the advantages, and the other part, we may speak about the disadvantages. Irrespective of all the collective things, irrespective of the cost, productive or anything, finally we say it as we need a product in terms of good result, good efficiency, and good overall well designed, provided it has to be in the form of miniature. So that's what we discussed with micro. Okay, next one is we speak about electromechanical. So first we discussed what is mean by system. You all know the meaning. What is mean by system? Everything are system. All the collective informations are carried out in a unique performing function that is called as a system. Systems may be in input and output. You may have a process, everything. That maybe you have learned it in your 1 year back. System dynamics. There was a paper you have learned system dynamics. There you may learn the variety of systems you have learned. What is mean by input and what is mean by output, and what is mean by process, or what is mean by open loop and what is mean by closed loop, and how do you consider the feedback, and how do you rectify the error, everything. Just 1 year back, at the same time, you people have learned of the paper called system dynamics. I hope you all got a clear idea what is mean by system. There you have represented the system either in the systems or in the signal or in various way. You have learned how to represent the system, how to write the transfer function of a system, everything you have learned. So now you all know the meaning of system. Second, we should know that what is meant by micro. So here we speaks about the product has to be developed, the product of 10 power minus 6. So when you wanted to reduce the size of your product, there are a lot of changes in the design parameter. That everything we are going to learn. At the same time, today's scenario, many modules, many latest technology, many design technology, with the help of computer or with the help of computerized program, we are going to interface all the hardware items converted towards the software module. Thereby, we are miniaturing the size through processors, chip, or sensor, yeah, whatever. That's what the chip or the processor, sensor, actuator only. We are this entire syllabus we are going to discuss here, so that you remember in mind. So you all know the meaning of micro. Then the third one is what is mean by electro and what is mean by mechanical systems. Why is you may ask a question, sir? Why instead of electromechanical, why not we go for electronic and mechanical or computer and mechanical? You may ask the question definitely. So remember in your mind, many products developed in the earlier days are from the form of mechanical devices. Or in the one aspect, if you speak about the equipment base, we speak about that mechanical. And in terms of power base, when we wanted to give a power or supply, then we may speak about the electrical systems. So electrical, so later stage, see after early stage, these two systems are separated. But nowadays, the during the advanced technique and during the more amount of populations are living in the society, everyone wanted to have the usage of the system, and everyone wanted to have the affordability of the system, and everyone wanted to have the access of the system, they, like user friendly. So thereby they are just interfacing the systems, like mechanical systems are interfaced with the electrical, or electrical systems are interfaced with the mechanical, or electrical systems are one more parameter introduced with the electronic components. Like that, there are a lot of interfacing challenges maybe happened. After this interfacing or interconnecting or interlinking, Thereby, we are developing new modules, we are developing new systems, and we are developing new type of ideology, new type of technology, new type of inventions we have as of now. Are you able to understand? So here, you people have come across with many mechanical devices, many mechanical equipments, many mechanical machinery parts, maybe in the lathe and other things, CNC machines, many things you have come across. Now, what is the objective of a mechatronics engineer? There are see, you people are something different from your mechanical engineers. Mechanical students are also learning many machinery parts like you people. You people also, so far you have learned many machinery parts like mechanical engineers. Now, in what way you people are deviated from mechanical engineers, and in what way you people have enormous hope in the society? So today's current scenario, mechatronics have wide range of scope in the society, wide range of scope in the universe. Wherever the mechatronics students goes, they can able to adopt in mechanical field, mechatronics field, even in electrical field, electronics field, and computer field. Yours is the only discipline. Try to understand. Will have wide amount of forum and collective amount of knowledge. That is what we speak about multidisciplinary. See, today's scenario, early days, researchers are will be in one focus. People go for mathematics research, they will only focus on mathematics. People go for science research, they will only focus on science. People go for electrical, they will focus only on electrical. But nowadays, remember new mind, people, people are preferring multi-talented skill people or multi-talented research people nowadays. I didn't understand. Early days, people worked towards on one target. Remember in your mind, people worked towards on one target. Even maybe your parents during that type of time of generation, or people like me in my early days, people worked or people focused towards only one direction or with a single target. Now, people are setting a target, and by keep on changing the parameter, they are just changing the entire design perspective and the entire scenario. So today, every people, they are just setting a target, but they are collectively working together, collectively getting ideas from various fields. From that, which idea they feel quite easy, design oriented, overall efficiency oriented, cost wise cheap, everything. Based on that constraints, they are using their ideas, they are incorporating their own ideas, and they are developing a new idea. That's why today people prefer multi-talented people. See, nowadays in industries, they don't want unique type of characters. They don't want unique type in one area or one focus area oriented people. They prefer people like you, because you people are eligible to work it in variety of field like multidisciplinary. So that is the major advantage you have it in the men's. Maybe these all things whatever I discussed right now, the importance of men's and other things, maybe your teachers or maybe your HOD maybe you discussed earlier. Okay, I'm not sure. Still, I'm new to this college. I know the worth of this mechatronics engineering, and today we have a high demand, and huge engineers are wandered in the universe in the form of mechatronics. So try to understand that you are doing a worth course, and your course is something different. You people are going to dominate the society, and you people are going to survive any field in engineering. That you remember in your mind. You will never ever rely on mechatronics. You people can collective multidisciplinary areas to have there every whichever area you prefer, whichever area you like, you can go and work after the completion of 8th semester. That is the real advantage you people have. See, early days, people who studied for economics, people will go to where, which place, banking sector, or some banking network or something like that. But this today, the same people, banking people, they are just going to software industry. How far? They are learning certain software courses. So like that, everywhere is today computerized. So that's why here, remember in your mind, electrical and mechanical systems are older systems, and very very important systems are the base systems in the society. So that's why that base systems are here collected here called it as micro electromechanical systems. So the mechanical part are combined with the electrical or driving through the electrical parameters. Thereby you are easily accessing your own machinery part. Now, the title may be micro electromechanical system, but what the real my mechatronics engineers are doing, they are doing after the interfacing with electrical, they are slightly introducing the concept electronics. Today, there are a lot of components are available in the market in terms of electronics, electronic gadgets, electronic modules, electronic softwares are available. Along with that, some software coding and some basic software knowledge in the outside forum. Thereby, you are interlinking all these resources, and finally, you are making a new product. That product may be a useful product to the society. That's what we are going to deal it in this micro electro mechanical systems. Now you understand. I hope you understood why we are just connecting electrical systems and mechanical. So remember in your mind, you are not only that thing. I just wanted to make it very clear. You are not only connecting only your mechanical and electrical systems. In general, electrical under electrical only there are many subdivisions. You have electronics, computers, VLSI, then embedded system, then large scale integration, and also in general they call it as electrical. Okay, well, that's why micro electromechanical systems. So being a startup with the mechanical parts and machinery parts, later part, you are going to drive, you are going to run, you are going to function, or you are going to interface your mechanical device with the help of an electrical circuit, with the help of help of a small circuit or a linear circuit or a non-linear circuit, then or through a electronic circuit, you are going to drive your device in an easiest way, in a well efficient manner. Thereby, you are bringing certain adjustments in the electronic side, and you are bringing a new system. See, today's scenario, a few examples. See, before go to the syllabus in the introduction to MEMS, and you may have your own computers, right? In the early days, the computers were so much of bulky and so much of bigger size. But maybe during my age also, it looks like a CRT screen. Have you heard about that CRT? Cathode ray tube. Later stage now, you people are using LED screens, light emitting diode screens, displays you have, and the size will be many miniature. Even the desktop computer is somewhat miniaturized. That means you people have a variety of a laptop, and even you people have a tab, you people have a smartphone. And today, earlier we had a phone with a bigger size, with a little amount of weight. But as years go by, nowadays your phones are weightless, and your phones are smartphones, and many things which you are going use storing it in your computers, everything are today you can able to store it in your laptop itself. Even if you have a very good amount of smartphone, wherever you go, you can able to access yourself, you can able to retrieve your data, you can able to help, getting the help to guide others, and even it's acting as a transporting through Google Map everything, we are getting the route maps everything. So everything this is possible with the help of whom? With the help of mechanical people, with the help of electrical people, with the help of computer people, and with the help of electronics people. So all these peoples are collectively together worked, and they developed a new product. That product will be with the various design parameters may be involved or incorporated finally in the forms of MEMS. Okay, one more example. In today's smartphones, and many type of sensors you may come across. Maybe being a mechanical backup mechatronics student, I'll tell you. Today you have a new latest model car. You may have a good car. Early days when we had an old model Ambassador and other things, the gear system was something different. Today you people are speaking about hydraulic braking system or pneumatic braking system you are speaking, and fuel consumption you are looking, and a lot of sensors you are introducing, right, around your car. And sensors comes under which area? In electronic. So sensors are developed through electronic. That you people will be taking, or being a mechatronics engineering, we are tracking that sensors, or we are introducing with our mechanical car parts or the machinery parts, and thereby we are creating lot of sophisticated techniques inside your car, right? Today's scenario, lot of facilities are incorporated in your car. Keyless entry, then fuel consumption, and the mileage, and lot of other specifications, certain warning systems, and certain accidental precaution system. Suppose if you by harsh driving or anything, unfortunately, making an accident, just imagine cars will have ABS system, right? Therefore, that type of sensors and the machinery driving device will help you to save your life. Earlier days, if people met an accident, immediately many people will die. Today also, people are dying. So I not deny that. At the same time, there are a lot of accessories. There are mechanical components and electrical components and electronic gadgets or electronic components are combined together. They are developing new modules or new technology. Therefore, we can able to avoid more number of death. That I can say that death is not in the provided deaths are minimized. The more amount of people who are losing their lives or something are minimized. That everything based on what? The connectivity of all this model, the connectivity of all this system, or the linking of all these protocols. That's what you try to understand. So even in your today's day-to-day life, many devices you may come across on a daily basis, even your smartphone or your computer, or even if your bike and everything. Today it's a you have auto start and everything. Earlier you people will not have auto start. You people have to kick and this you have to start your vehicle. But nowadays you will have a facility auto start your vehicle. That everything based on this electronic components which is driving or which is interfaced with your mechanical device and driving your vehicle. So, and today, even if you find out any of your storage devices like your batteries and your reunitable system, and even while you are traveling in the buses or flight or airways or trains everywhere, lot of mechanical modules are now in terms of miniaturized provided. All the mechanical components are now interlinked with your electrical and electronic components. Therefore, you are getting more amount of efficiency, more amount of time saving, more amount of easy understandability, and more amount of user friendly. See, one more thing I just asked you. Today, without knowing any processor idea or processor module or any computer coding technique or anything, will you able to access any type of mobile? Yes or no? You can, right? If I give any advanced mobile in your hand, you people know that how to start, how to install the app, and how to run the things, and how to access and how to retrieve all the data within a minute. Am I right? So that means every modules are now developed in terms of user friendly. That you never forget. So that user friendly, we have to focus, or the efficiency oriented we have to consider, and at the same time we have to focus on cost. But nowadays, remember me, maybe the productivity cost may be initially it may be high due to linking many parameters. But after some years gone, after trial and error, the models are revised again and again. The models may be cheaper. So whenever any new products are comes into the market, it may be a little costly. That you try to understand. A lot of new technology, new methodology you may have, provided all this technological cost and implementation costs are little higher when you send a new product to the market or when you go for commercialization. So try to understand it. Or remember, when you go the later part, after certain revision, after certain modification, after certain trials and errors overlap or combined, that then immediately the prices will be reduced. That's why maybe to this year, if they introduce any mobile phone or any new car or anything, the initial cost will be high. Maybe after a year or after 6 months or 2 years, if you refer the same prices will be substantially reduced. Why? Maybe in the initial stage, due to the economical base, it cost may be high. But later on, in order to bring about the customer satisfaction, customer orientation, and in order to cover or in order to bring more customers towards that product, they are trying to reduce the price. So that is why this type of today's scenario, multidisciplinary plays a vital role, and multidisciplinary field like mechatronics have a high boom in the society in hardware part, and you people today's world people are relying more on the mechanical parts or the machinery parts, or every complicated systems are driven or driving or functioning through this electrical or electronic components. With that, they are inventing new ideas, inventing new products, inventing new technologies to the society for the betterment. That is the real objective of learning this mainstream. So micro electromechanical system, remember my mind, you all know the meaning system, you all also know meaning of micro, then why do you speak it as electromechanical? See, in electro, we speak it as many components like we speak about power. In electrical, we can speak about how we are. When you did not learn, if you did not, do not come to know exactly what is meant by power and other things, at least you know that the basic power circuit and other things you know that, right? You have learned to. So, electrical supply, electrical devices, everything you come across. Along with that, many electronic devices maybe you have learned in 1 year back. You have learned a paper called linear integrated circuits, or one more paper called digital systems and digital systems and microprocessors. Maybe I hope you learned, you people have learned just 1 year back, maybe through online classes, or maybe initially in the offline classes, like in the college you have learned. Once the lockdown begins, maybe you have learned through online. I hope if you just recollect or brush yourself, you will come to know many gate circuits. In digital systems, you have learned about gate systems, like AND gate, OR gate, NOT gate, XOR gate, maybe you have learned. Okay, flip flop, sum of product and product of sum. These are the things you multiplexer, demultiplexing, and frequency time domain, frequency time domain and frequency domain you have learned. And the basic function of the processes you have learned, like microprocessor and other things you maybe you have learned. And one more important thing, uh, we speak about the processes. So these processes, everything early days, the things which you learned like gates and flip flops. These are the clock modules may be used during at those time of developing a processor. But nowadays, the processes are something different. Processes are miniaturized. Processes are highly modified with the help of latest tool like microcontrollers or embedded systems, or very large scale integration areas like it, or through some computer programming. Maybe you people have learned Python coding. See, early days, when you go for any programming, maybe you have learned computers in your first year. Maybe when you wanted to do a C program, how many lines you hardly it will take for a simple function also. Simple program, it will take around 100 lines or 50 lines, 80 lines. But if you are very strong in Python coding, it will take around 10 lines or 15 lines. I hope you have learned Python. It's a basic coding in your first year computers called the Python coding. There maybe you have learned the codings are very very simple and very very reduced. The lines of the coding are reduced. That means during all the advanced techniques that I remember. So like that. So here also, yeah, you have learned your gate circuits and everything. With the help of gate circuit, everything, linear circuits, or the last year at the same time, integrator, comparators, certain type of controllers you have learned. Proportional, integral, derivative, and the big combination of proportional, integral, and derivative controllers, and the industrial oriented tuning of PID controls may be learned in your system. So these all controllers or everything are together are driven through your electronic components. Thereby, we are optimizing the function in a reduced manner. Are you to understand? So that is the real objective behind your micro electromechanical system. So remember, this entire subject will be focusing much on about what is the importance of micro, why we speak about the today's scenario micro. See, today not only micro, we are speaking about nano, pico. See, micro is 10 power minus 6, nano is 10 power minus 9. Just imagine the size. then pico is a 10 power minus 12. Still they speak about what? Micro only, nano, and even nowadays people speaks about nano materials. But when you go for pico and all, every of your product will be much thinner and than the old material. So like that, lot of research works are going on. And what are all the basic electrical devices which we are going to deal, and what are all how the mechanical devices are incorporated here, and what are all the general systems we are going to do. So these things we are going to study in this paper. And one more example, maybe in your digital systems you have learned about display devices. Many display devices maybe you have learned, right? You all know that seven segment display, or liquid crystal display, or LED display. Even in your houses, you may have a good TV like LED TVs, and you may have. Earlier we had the CRT, cathode ray tube. It's a bulkier, but nowadays it's wall mounted. You can easily put it on your wall, and it will not occupy much places, and it will not take much area. Am I right? So remember your mind. So here, uh, all these display devices are earlier in bulky in nature, but nowadays it is miniaturized. Now, with the help of wherever you go for display, see, lot of display devices will come across in your entire career. So remember in your mind, all these display devices, even you may have your smartwatch, you may have, I'm not talking about analog, I'm talking about digital. So your digital displays are in the railway station, or in or bus stands, or in the colleges, or wherever the printing mediums, wherever visually you wanted to see any display devices, everything are the components which you learned in your linear integrated circuit, like op-amp, operational amplifier, then integrator, then comparator, then micro systems, everything you learned. So that products are now going to combine with your mechanical systems. You will understand. Even your traffic light control, maybe in the traffic light controller, you all know that there you have displays like three colors. All these displays, everything you have learned through in the form of what? Electronic modules. Same electronic modules are now converted, connected in your mechanical device. That is the real objective we are going to take in this paper. Introduction to MEMS, micro electro mechanical systems. In short way, we used to call it as MEMS, MEMS. That you remember now. So, uh, before going to the depth of your syllabus, another question. Before start your syllabus, so paper is one of the easiest paper you can easily learn, and it is one of the elective paper only. And in your first unit, before learning this paper, what is the real objective we wanted to fix for this paper? See, today's class I just explained to you about the outline of the MEMS. Why we are learning this paper? Micro electromechanical systems. So the four meanings I explained to you in a brief manner, in an understandable way, provided. What is the objective? Say, whenever we wanted to start any work, or whenever we wanted to go further, or whenever we wanted to move further, remaining to you, right? We wanted to set a target. We wanted to set an objective. See, if you want to go to one place, you set a place, right? You set a place, then you plan. Either to that place, will I go by train, or will I go by bicycle, or will I go by airways, or will I go by buses, or truck, or by your own vehicle, or anything. That everything, once you set a place, after that you start thinking, will that place is accessible to reach by these devices. For example, if you set a interior area in the northern part, in the hillside area you have set, then once you set a place, after that only you start thinking about, will all these devices or transportation devices are accessible to reach that place? Which are the easiest ways to reach the place? What are all the guidelines behind that? What are all the transporting medias are very affordable to reach the place? Everything we look into that, right? After that only we will decide through which transportation ways we can go to that particular target. So like that. So remember in your mind, whenever we wanted to learn something, or whenever we are learning any paper or any project or any idea, that you remember in your mind, We have to set the objective. See, dear students, next year the same time, you people will be doing your project. You are doing this up to the 6 or 7 semesters. Whatever ideas you gained, whatever knowledge you have gained, whatever you learned throughout this area, mechanical things or electrical or electronic or computer knowledge, everything are collectively together, and you are going to develop a new product. When you want to develop a new product, that time you are going to put all these collective ideas in one floor. Thereby, you are going to develop or you are going to invent a new ideas. See, sometimes the idea may be work out or idea may not be work out or just a minute. Okay, so 37 students have enrolled. Okay, good, thank you. And so sometimes when we develop a new product or when we find a new solution or something, sometimes it may not be a successful one. Sometimes it may be a failure one. But remember, failure or success doesn't speak about this area. We never speak about the failure or success. Remember, what sort of collective idea we put in that area. What sort of new retrieved solutions you brought, and what are all the practical implications you have faced? What are all the complexities you people have faced? That only will help you or will enhance you to go for the next level of protocol or next level of platform to stay. That you remember me on it. See, everywhere a lot of new inventions, products developing is going on, right? Do you ever think that will all the model to be a successful one? Certain models may be a failure one, and models will be everything will be successful after fine tuning again and again, after hard working of again and again, after putting lot of collective ideas together within the right stimulated time in a correct manner. That is important. Sometimes we may have good ideas, but we do not know exactly where we are supposed to put the corrective idea. That is important, right? Where I wanted to apply my idea. When I wanted to apply my idea, what are all the drawbacks behind that? What are all the accessories I have to provide or I have to consider? And what are the fabrications I have to consider here? Everything I have to look into that. And sometimes when we have good idea, when we are unable to get certain products, sometimes certain products may not be available in the market. At times we have to think about the alternate ways. We have to think about the alternate ways or the other source of product which is available in the society. By getting that product, what are all the basic triggering ideas we can put to that, so that we can change the idea. So like that, everywhere, whenever we wanted to develop a product, there will be lot of restrictions, there will be lot of constraints, there will be lot of commitments, and there will be also a lot of challenges and hurdles you people will have. To overcome the hurdle, we have to we have to collectively brought all the ideas together, keep on fine tuning, keep on reforming, keep on transforming, and so that we can be able to get a new solution or we can be able to retrieve a new idea. This is how your people are going to do the project in the next year. Okay. Now, certain applications we are learning on a daily basis, right? Maybe in your 6 years or 7 years back when they introduced this WhatsApp, I hope 7 years back. That time there is no much formalities are there. Like in WhatsApp, we can able to send the message and receive the message. The later part, they are fine tuned. When they introduced only you can send the message and receive the message. After that, there are a lot of features like exchanging your video calls and audio, then recording, then sending lot of images, sending any type of files, and saving large amount of information, something like that. They introduce how every time whenever they introduce any new model or anything, initially it may be certain restrictions, certain limitations you may have, but after some time, remember in your mind, you can, by your trial and error, by your periodical updations, by keep on working in the same area in a customer-oriented way, therefore you are about to introduce many new ideas. So therefore only that system will be accessible to every human being. Today's scenario, Many people who are educated or who are uneducated are ready to use the WhatsApp or any other electronic gadgets. How far it is possible? Early days they cannot. Early days only the people who are educated or who learn something or who are about to understand what others speaking will be able to operate this type of devices. But nowadays, how the scenarios have changed. Nowadays the scenarios have changed in a different way. Nowadays, people's education is not essential because every products are customer oriented and user friendly. And if the product in a country like India, we have 138 million of people, millions of people we have it in our country, nearly 138 million, just imagine. Hardly some 40 to 50% people will be educated, right? That means every product has to be commercialized and every product they have to earn more. That means that product must to be a customer oriented, the product must to be a user friendly. That's why keep on refining and keep on changing certain things. They are bringing new ideas and they convert the early product into a user friendly new product. That's why today's scenario, everyone can be able to access WhatsApp or a Signal or Telegram or any app. So, recently only we speak about the Telegram and Signal app. Early days we are there only on WhatsApp. Maybe after February 8th, we do not know how many of us are going to use WhatsApp and other things. Okay, that will be better. Okay. So here, so we are setting an objective is much important than the other things. So once you set objective, so here in MEMS we are setting six set of objectives. So the first objective is to provide necessary fundamental knowledge in manufacturing and packaging of microsystems. So when you are saying that your system has to be in a micro level. You all know the meaning of micro. I have explained in a brief manner. That means you are setting a fundamental knowledge. You need to have a basic knowledge about the manufacturing process and the packaging. Now are you able to understand why we speak about the packaging? Packaging or if the packaging is more complexity, so the equipment will be in bulky in nature. So therefore, we have to think about the packaging. So here, that's why we should focus more on. We should have little knowledge on the fundamental knowledge in manufacturing and packaging of microsystems. And the second objective is to impart knowledge of behavior of mechanical and electrical elements at microlevel. So we also need, being a mechatronics student, you also need certain understanding, certain behavior, certain knowledge on mechanical system, the electrical system, and the mechanical elements and the electrical elements at microlevel. Okay, here what they are trying to speak about mechanical elements. What are the basic mechanical elements learned? These three elements are called as basic mechanical elements. One is called as mass, the second one is called as spring, and the third one may be called as dashboard. This is how we used to describe a mechanical system. Like mechanical system is basic mechanical. See, mechanical in the sense it's a vast area. It's like an ocean. Mechanical and electrical are like an ocean. You all know that. But the mechanical basic elements are described in such a way that so remember in mind. Therefore, mechanical devices may be a mass, spring, and dashboard. Dashboard means the piston moving inside a cylinder filled with certain fluids are called as a dashboard. That is called as dashboard. This all which you have learned in your system dynamics. Okay. And there maybe in mechanical systems you have applied your Newton's second law of motion. Maybe your sum of the applied forces equal to sum of the opposing forces. Whenever you have certain applied forces in any system, definitely remember in your mind, you may have the opposing forces either through that body itself or by the certain external forces. So that you remember in your mind. Same thing. If you convert it in terms of torque, when you speak in terms of force, we are saying that sum of the applied forces equal to sum of the opposing forces. And at the same time, in terms of torque, when I'm speaking, the same concept. Sum of the applied torque is equal to sum of the opposing torque. Whatever torque you have applied, definitely you will have an opposing torque. So here we will speak about two parameters. One is for the applied and another one is for the opposed. So these are the two things you just remember. And uh, This is for your mechanical things. And the next part is electrically. So electrical, what are the basic electrical elements you come across? Maybe in the first year, you have learned the electric circuits or basics of electrical engineering. Even you may have a lot of house appliances in your homes and other things. You may have a power supply. You may have a lot of electrical appliances in your home and everything. You definitely you may come across. Many electrical failures or fault things may be done by you only in your home. You need not expect electrical people to come and rectify. Definitely, being a mechanical or mechatronics engineer, you yourself have little hardware knowledge. Therefore, you yourself are about to solve many issues in your home itself, right? Even if anything gone wrong in your fuse carrier or something else, immediately you know that how to rectify the fuse carrier issues and how to drop the voltages to rise. For example, in your house, only one phase is working, remaining two phases are off. How to trigger or how to adjust by from the panel. These all things you know that, right? These all are basic things. Nobody can teach you. By visually seeing, by visually have some basic knowledge, you are about to operate all these devices. Am I right? Okay. So here, what is my question is, what are all the basic electrical elements? Electrical elements in the sense, remember in your mind, mechanical we so speak about that mass, spring, and attachment. Therefore, electrical you remember in your mind that we speak about uh, uh, so the first one is a resistor and the inductor and the capacitor. Definitely you might come across resistor, inductor, and capacitor. So these are all the three basic elements maybe you have learned. With these basic elements, okay, that elements are converted in a big manner by connecting all these devices, and by series connection or parallel connection, they are developing new ideas. Okay, these are all the basic elements. Okay, what are all the basic electronic elements? Maybe last year you have learned electronics lab and other things in your fourth semester or third semester. What are all the basic elements you can now you remember? What are all the basic elements? Have you remember about basic circuit of PNP transistor, NPN transistor? Maybe in your plus two in your school time itself, you maybe studied in your physics. PNP transistor and the NPN transistor, then followed by diodes, then rectifiers, then gate diode, then thyristors, then SCR, silicon control rectifier, then MOSFET, and these are all called in basic components of your electronic. Definitely, maybe you have not diodes and other things. Diode, definitely you come across that. Am I right? So these are all things you should remember in your brain. So here the second point is we have to have little import knowledge of behavior of mechanical and electrical elements at micro level. So what I mentioned right now are called as basic electronic elements. So in a micro level, how do we go ahead? In what way we can consider these all basic components in a miniaturized manner or in a micro level manner? Okay. See today, maybe you also saw some chip. You may heard the word chip, CHIP, chip. See, chips size will be very small. Appearance will be very small, not bulky. But do you know that each chip will have do variety of function, variety of module, variety of operation? Am I right? So that we speaks about here as the miniature or the micro level. Now every modules are miniaturized in size and miniaturized in nature, thereby performing more amount of operation or more amount of actions towards the target. That is very very important. That is the real objective. Third one is to emphasis on electrical and thermal actuator in microsystems. So here we are going to deal about the electrical and thermal actuation in your micro. So electrical we have discussed, and again thermal. Thermal again you comes under your basic area like the mechanical or machinery areas. Speaks about in the terms of temperature devices. Certain devices are called as what? Temperature devices or temperature oriented equipments. That devices may be considered here as the thermal. So actuators in the microsystems. Okay, so here in this subject, we will deal in the later part. Sensors are plays a vital role, then actuators are plays a vital role, then the automations are plays a vital role in terms of micro. Then fourth objective may be emphasis on piezoelectric and magnetic actuation in microsystem. First one is piezoelectric. See, there are piezoelectric materials are available. Quartz material, uh, galvanized material. These are all called the piezoelectric material and magnetic actuation in microsystems. How the magnetic property, electrical property we have discussed. How the magnetic, as per the law of Faraday's law, second law of induction, uh, EMF induced in a circuit is directly proportional to what? Rate of decrease of flux. That's what the Faraday's law of electromagnetic induction. So that type of magnetic effects, how far it will help you to go ahead further for micro systems. Because you are dealing mechanical parts and electrical parts. Whenever you have a machinery parts are more, there you will have the mechanical effect. When you have a more amount of mechanical effect, there you remember in your mind you will have a lot of magnetic parameters. You have learned about diamagnetic, paramagnetic, ferromagnetic. You have learned. So these type of magnetic properties are the property of a magnetic materials are synthesized here. So that idea has to be considered here when you go for microsystem. See, remember in your mind, uh, we are easily speaking that in micro implementation. Any product has the size has to be reduced. That means more amount of challenges we have, more amount of reliability reliability is required. That you remember in your mind. That maybe by speaking the simple word, I am using micro in the easiest way. Micro is not that much easy. Try to understand that. We have to work and we have to think about various parameters. Finally, only the size may be reduced in micro level. That you remember in your mind. When you and one more important challenge, remember in your mind. Whenever you go for micro level products or whenever you go for sensitive materials, there we speaks about sensitivity. Every materials are sensitivity oriented. Or you to understand, whenever the devices are reduced or miniaturized or converted in a micro level, there the warnings will be more and their the safeguarding will be much important and their carrying much more important. Taking care of that sensitive devices are plays a vital role for the challenge of engineers. Every component will be much sensitive. That's why have you ever heard about that? Suddenly people will say that their smart devices is not working. Sensor gone, sensor is gone. Sensor due to some water evaporation or during rainy season, through I come across thereby my sensor gone due to my sensor absence. My device is not working. Something like that people used to share, right? So remember in your mind, sensors plays a vital role. So here we are going to deal about your sensors, then we are dealing about actuators. So fourth one is microsensors and actuators is designed by piezoelectric and magnetic actuation. So magnetic properties also we have to consider. Electrical property we have to consider, electronic properties we have to consider, then magnetic properties also we have to consider. So variety of properties have to be considered into account that you will remember in your mind. Then fourth objective may be gain knowledge on different applications of MC devices. So get knowledge on different applications. So we are learning things, but at the same time we also should understand. We should know that we should every individual we should know that what is the uh, applications we need. See, whenever we learn something, I told you initially we set a target that when we reach the target, then definitely it might be a product oriented. That means it's application oriented, or it may be a new module oriented. That is much important. So here, learning this paper is not important. After learning this paper, how this paper is much important in the society, how these men are playing a vital role in the society and plays a vital role for the human being's life and plays a vital role for the engineering perspective. Everything we have to look about that we speaks about in terms of It's one good application. It may be many gadgets, any gadgets based on your electronic gadgets. All your electronic gadgets, your smart devices based on what sensors like that, based on your MEMS application that you remember. Your MEMS application only, your sensors and actuators. And the only important thing is your robots. There are variety of robots you have. Movement type robots and unmovement and medical robots. Many things are available. So that you remember in your mind. Uh, Many places. We should just a minute.
Just turn the camera just for the snapshot.
Just a minute.
This one, some more people are having a cycles. Right? So the first many of them do not taking bath maybe in the morning. Not really. That's a question. Doesn't it? Today morning I saw a news that somebody has not taken bath for 65 years. Done. 65 years. And it's still alive. Yes, attendance. Yes. Yes, relaxation. Okay. Right. Alright, so good morning everyone. We will continue the journey that we started yesterday. And of course, after this talk also you will listen to me. After the second part of the neural network, especially the different of protein neural networks, we can check what we as follow conversation. But this one is exactly some sort of extensions of this lesson is here.
Sorry for the
There's
delay.
one idea
And
is saying that
the staff is coming. Now, listen all of you.
how we will kind of take advantage of these areas for logging from.
Okay. Now, sorry for the delay. Just 2 3 minutes. Okay. So here we have to the fourth one. We have discussed briefly piezoelectric and magnetic actuators and microsystems, and fifth one expose all the applications. So here I told you one single application. I told you the smart devices and all your robots. Remember me, mind, all your robots with the latest technology. Maybe you people are also about to design certain miniaturized type of a robot on the forthcoming days in your project. There, more amount of sensors, more amount of actuators, or you are going to place it inside your robot. That is also a major design perspective why we are learning this paper. That you remember in your paper. And final objective is introduce computer-aided simulation of microsystems. Computer-aided simulation of microsystems. See, everywhere, any device. Finally, nowadays we are speaking about IoT. Have you heard about IoT? Internet of Things, right? Any module, anything, any idea, any hardware devices, finally the work is converted towards with software oriented with the help of computers, with the help of laptops or whatever smart devices you have. So everything we need little amount of essential basic knowledge about computers, the usage of computers, how to use the various tools behind your computers. So always being a hardware, whenever we develop any hardware module, finally that hardware modules are converted to your software module. So that you remember me. So there are important six objectives now we have set. So I hope you can remember. And the next one is okay. Well, I told you whenever we learn something, we have to set an objective. Okay, now you set all the basic objectives, six set of objectives you have discussed. Finally, your objective is application oriented. Am I right? So, and finally, all your applications are focused towards your computer analysis or computer software oriented. Okay, fine. Now, uh, setting an objective. Okay, we have set a variety of objectives. If I don't fulfill my objective, what is the use of developing a MEMS product? Are you able to understand my question? So I am willing to learn new things through micro electromechanical system, or combining a mechanical or interfacing my mechanical system to a electrical system or an electronic system to miniaturize my size in the form of micro. Okay, fine. That is my real objective. Okay, that is the essentiality of this paper. Okay, I have set variety of objectives. I wanted to learn the fundamental. I wanted to learn the behavioral mechanics. I wanted to learn the electrical and electronic properties parameter, then the piezoelectric and magnetic properties, then the applications, and finally, all these modules are combined together with the help of software-oriented or computer-aided simulations. Fine. I set a objective, and if I don't work towards the objective, what's the use? I may not have any product. And so once I set an objective, I should try to fulfill all the objectives of the possible objectives. Sometimes I set here 6 objectives. Sometimes I may not able to fulfill the 6 objectives that you remember in your mind. So remember, always we need not be able to fulfill all the objectives. Certain objectives maybe we have to skip due to certain practical difficulties, or due to certain practical uh, practical challenges, maybe some hardware challenges, maybe some cost to it oriented difficulties we may skip, provided when I should reach to my target, or when I should reach to my product, I have to fulfill the maximum number of objectives which I have set. That you remember in your mind. So even in your careers, after you leave from the college, when you said that okay, I wanted to go to UK, or I wanted to go to US and I settle, you set a target. Before I wanted to go to US or UK, what are all the prerequisites I need? And being a mechatronics engineer, what are all the basic studies I have to hear? What are all the pre-exams I have to clear? Then in what way I can able to fulfill the financial funding, or will I get scholarship from the particular university in UK or US for higher studies and the job and other things. So like that, in the outline form, you set all the objectives, then you work towards that objective. Thereby, every stage of your work, you are trying to uh, complete each objective stage by stage. Therefore, finally, all the objectives are collectively together, and you reach a product that is called your outcome. So that means the outcomes are much important than the objective. Setting an objective is important. Every individual will do. Sometimes we will set the objective and we will not follow, and we will not reach the outcome, or we will not reach the target. That's what our real life. In our day-to-day life, if you see that many things, many ideas, many vision and mission we may have provided, will we reach the mission or vision what we planned in our mind? Never. The reason is we are setting the objective and we never worked towards the objective. So always we should, being an engineer, we should work towards the objective. Then only my objective will be completed, or my task will be completed one fine morning. Therefore, I can be able to reach to my destination, or reach to my product or design. So the first outcome will be, so 6 objectives we have set. Therefore, we are expecting 6 set of outcome. The first one is, the first outcome will be understand the operation and manufacturing of equipment. Now we should know how the mechanical or electrical devices are working in the operation, and how the companies are manufacturing these products in the size of micro level. So that is very, very important. So manufacturing is not a easy one, right? Am I right? So it may be a, remember in your mind, it may be a hardware manufacturing, or it may be a software oriented. But manufacturing plays a vital role when you go for implementation. The first one is manufacturing and the operation. The second outcome is analyze the behavior of MEM systems. Okay. When you start developing your manufacturing or operation, certain behaviors. What is meant by behavior here? Behavior is like a characteristics. See, in student life, people say that behavior, but it means what? The character. How the student, how this student will be. Something like people will ask, right? That indicates about your character, or the nature of the student. That's what I will tell. But in the industrial manufacturing, we speaks about the characteristics. What are all the characteristics? When temperature rises, what will happen? When more amount of current occurs, what will happen? When the amount of voltage drop, what will happen? Then what are all the practical uh, difficulties for x-axis and y-axis? And when the torque rises, what will happen? Torque is proportional to current, what will happen? So these all characteristic studies we have to do. See, when we go for manufacturing, definitely temperature plays a vital role in manufacturing of any machineries or mechanical device. That means that temperature versus torque or temperature versus the universe values we have to consider. So temperature also plays a vital role. Temperature. Then we can speak about one more word, vibration. Right? All mechanical devices are more vibration oriented. How to avoid vibration? That is a different part. Then how to occupy the space, more amount of
Hello, sir.
yeah, can you hear?
So the slide is still on introduction page, sir.
Yeah, still I'm not completed the introduction.
Okay, sir.
Okay. I'm not completed the introduction. Still, I'm speaking about the outline lay of your mens. Okay, so these all general ideas I just wanted to give. Later stage, we'll go to the slide. Don't worry about that. Okay, can you hear?
Yes, sir.
Okay. Don't think that I'm moving to slides. Slide number is one only. I'm just giving a collective overall ideas why we are going for this paper and what is the objective and our outcome. Then the later part will go to the syllabus. Never panic. And together we are going to learn every material and everything. Definitely, I will post everything on your Google Classroom portal. Need not worry about the subject. Got it? Okay. So. So the next one may be a behavior. So here I speaks about behavior in the sense the temperature and all the characteristics we have to study. Then third outcome will be design micro sensor and actuators by electrical and thermal actuation. So here you are designing a micro sensors and actuators. I told you earlier, right? In MEMS we much focus on sensors and actuators. So that design part in micro level, in what way is possible. So what are all the practical difficulties, in what are all the components involved, everything we have to study. Then fourth learning outcome will be design microsensors and actuators with the help of piezoelectric and magnetic properties. I told you the quartz materials are the piezoelectric material. Why we go for the piezoelectric material? Have you heard about transducer? You may definitely come across a transducer. Transducer is what? Converting one form of energy to another form of energy. For example, pressure is converted to electrical, or stress is converted to electrical, or vibration is converted to electrical, or movement may be converted to electrical. Not only electrical, even other type of thing. That means symbolically remember, these piezoelectric materials are placed over here in any part of your mechanical design, provided it is a form of changing or converting one form of energy to other form of energy. So always your transducer means, remember in your mind, transduce in general we call it as transducer. There are variety of transducers may be available in the market. So depends on our mechanical usage or the mechatronics usage, we may choose according to the particular type of transducer. So the basic objective of transducer is converting one form of energy to other. For example, only I told you, maybe vibration may be converted to electrical, or stress may be converted to electrical, or movements may be converted to electrical, or pressure. And how much amount of pressure you are applying, that amount of change in pressure will be converted as an electrical quantity like that. So it is converting one form of energy to the other form of energy. So changing one form of energy to other form of energy, piezoelectric. Then magnetic properties already I have discussed with you again. So magnetic, in the sense we speak about much on Faraday's law of electromagnetic induction you studied in your physics of your school days. So that magnetic property and the magnetic induction and the magnetic behavioral changes we have to consider and we have to look into that. So that is the fourth object, the fourth outcome. And the fifth outcome is to gain more knowledge and more different applications of all the MEMS devices. So not only developing this module, I told you earlier one important point. While developing this module may be a failure one. Do you ever think that failure will spoil all your ideas? Never. So ideas remain same. Maybe ideas will be converted in different way, or ideas may be well tuned on the later stage, or ideas may be trapped by getting help from somebody and converted in the other form. Okay, ideas will not last forever. That you remember in your mind. Maybe my product may be due to certain changes or certain situation, it may be a failure one, but my ideas will never live for a long time. In order to go further, or in order to deeply go further, deeper and deeper, and get new product. That you remember. So here, I need to have an adequate amount of knowledge in the form of applications. Whatever all the applications we have in the society, that all the applications I should think about certain knowledge. See, knowledge in the sense I should know what are all my MEMS components are used here. What are all my MEMS devices are used in this new product. That idea is essential for us when we develop a new product. And the last outcome will be to simulate simple microsystems. Okay, you have implemented, you set an objective, and finally, after reaching one by one objective, finally, when you reach the sixth objective, you have a new product. When you have a new product, my question is, will the product have to be run either in a mechanical manner or in a computerized manner? When you wanted to have it in a computerized manner, that means we wanted to drive the material. Let's see, we have reduced all the components in the terms of miniature. Okay, wow? Okay, so therefore, we wanted to drive the devices with the help of a microcontroller or a computerized oriented program or some interfacing devices. Maybe in the same semester we will be learning microcontroller also. And microcontrollers also we are going to use here as an interfacing device, as a driving force. Maybe earlier you have learned about microprocessor. So there we can also store the memory and other things. So here in microcontroller we can able to store the adequate amount of information. Slightly advanced if you go for you can go for that embedded controller. Then you can go for that computerized latest programming. Through programming we can control so variety of things. So that means we should have the we should finally drive our product with the help of simple computerized programs. So this is how we are going to drive the entire MEMS system. So here, six objectives we have set, and the six objectives we are going to fulfill. Once we are going to fulfill the six objective, therefore my entire system will be call it as a MEMS system or micro electromechanical system applications. So this is how we are supposed to overall. This is how the overall objective and outcome I will explain to you. And as per your syllabus, so still remember in your mind we have not gone into your syllabus exactly. Now just what your syllabus, what they are trying to as per the standard of university, what they wanted we to learn micro electromechanical systems. We'll have a discussion. Then in the next class onwards, we'll go to the directly to your syllabus, and we will learn much things as per the prescribed university syllabus, or the general ideas whatever I have and whatever you people also have. We will have a mutual discussion. Thereby we can also improve our ideas. See, certain ideas I may able to give. Certain ideas are much better than you people may have, because you are all younger students, and they comes across many devices nowadays and using many devices. That means you people will also have adequate amount of knowledge, but we do not know exactly what sort of devices these are. See, we have come across many sort of devices on a daily basis, but we do not know exactly where we are using that device and where we are applying this one, and where what is the importance behind that. Certain times we do not know. That everything in a collective forum we will discuss, so that at the end of the semester we will discuss with some meaningful application in the society, and if possible, if the time permits, we will develop our own module for the society usage, or at least some new ideas to the society. Maybe in your 7th semester, if the time permits, we will convert it as a product oriented. That is the real objective. Whenever we learn something, finally that we have to convert it. As we all together, myself and all the 36 members, we together in a collective forum, our collective ideas with a set of different ideologies, we will convert it into a product. So in your unit 1, as per the SRM syllabus, Unit 1, we just speak about your introduction to MEMS and microsystem and the fabrication process. So how we are going to fabricate the devices. Any device we want, whenever we wanted to start, we need to have a fabrication. So maybe the earlier classes, 1 year back, you have learned IC fabrication. Maybe you have learned etching, and then wafering, overlapping, all those things you have learned in your linear integrated circuits. So here, how we are going ahead for fabrication, and what are all the elements of MEMS, and what are all the applications, and what are all the characteristics, what is the intrinsic characteristics, and what is the extrinsic characteristics, and what is mean by miniaturization? What is the law says about your miniaturization, that we have to discuss. Then we have to discuss about the silicon material, the silicon components, and the polymers, which is essential for this paper. Then we have to speak about photolithography and how the ionic implantation and the diffusion takes place when you speak about the silicon material. You all know that silicon materials. So carbon and silicon materials, when we speak about that, we should speak about the ion exchange, that or ion implantation. So ion implantation or diffusion or oxidation, we have to think about that. So these are all this diffusion, oxidation, implantation, and with the lithography, all those things are comes under your category of appreciation. So there you have the three set of appreciation. One may be a chemical one, and the second one may be a physical deposition, and the third one may be a surface one. And finally, what is meant by etching? Then finally, how to after evaporation, how we go for dry etching, and finally, how to package. In what way we are going to package the system. That is your when it comes to an end of your unit one. Okay, so in unit one, the basic things which we are going to learn is about the overview of the subject, then the basic elements, and what is the law. See, every principle behind that, you have certain law, right? Some fundamental law you may have. Without some fundamental law, without some fundamental basic design ideology, we cannot go ahead. Some basic knowledge, some basic prerequisite only, we can go ahead further and we can able to develop new things. So that you remember in your mind. So here, uh, uh, we are mainly focused on fabrication. So in the fabrication, we speaks about the silicon material, then diffusion, oxidation, vaporization, then finally etching, and finally the packaging system. So that's what we are going to deal with your unit one. And in unit two,
So we can't hear you, I think. Oh, left.
Sir is there or not? Can we leave?
हाँ और क्या भाई.
चलो भाई, चलो चलो.
15 मिनट से नहीं आया, भाई निकलते हैं. Sofras, you asked? Where is he?
wanted to ask you, when my connection gets disconnected, those are online. Kirti Vasan, please can you able to hear me?
Yes, sir.
Actually, suddenly my connection get disconnected.
Sir, it was about 10, 25, 15 minutes back, sir.
See, next class onwards, if anything happens, immediately you just call me. Okay, I'll just tell my number. Just
Okay,
note down the
sir.
number. 98409.
Just 1 second, sir.
Yeah.
Yes, sir.
98409.
98409
76370.
76370.
Immediately you just call me. Okay.
Okay, sir.
And one more important thing, and right now I'll be taking the attendance for you. And one important thing, maybe some 10 minutes, like finally I have talked about the unit 5 only. Maybe the next class we'll discuss about that. And remember, weekly we have 3 hours class, okay? So that means I'll post the timetable by today in your Google Meet. And today I have taken 2 hours continuously. And the first day order, 1 hour is due to your enrollment I missed. Okay, due to your enrollment, first day class I did not take it. And Friday, 5th day order, 7th hour I have class. Okay, so 7th hour I have other laboratory. So that's why 7th hour I will not be present. That information I will post it in your group. Are you able to understand? So today by 9 to 10:42 hours class is over. And 1 more hour will be on 5th day order. Day 5 in the sense, I think, I hope Friday. Friday 7th hour. 7th hour ultimately I have other laboratory, microcontroller laboratory. So that time you need not connect. Okay. If any changes or anything, I will inform to you by your Google Meet. So that message I will inform to you. Okay. So weekly the 3 hours classes only you have 3 hours. So one Monday's class due to your enrollment is gone, and today 2 hours continuously I have taken. Suppose in future classes, if I need or if I wanted to cover extra things, that time I will inform you. So this week, 5th day order, 7th hour you need not connect. But if you wanted to connect, I'll inform you in prior. Okay. And suppose if any student while connecting here due to network connectivity or anything, if you missed, please, I have given the phone number just now to Kirti Vasan. Get my number and write your registered number and your name and message. Send me through WhatsApp. Just now I gave my, I told here only. I hope everyone noted. Maybe Kirti Vasan has my number. So get the number from him and just WhatsApp message. Sir, I'm so and so. My registered number is this one. Today, due to this connectivity issue, I have lost my connection. Please put the attendance. You just message me. Okay. So no issues about your attendance and other things. And just a minute, let me take the attendance so that you can find out. Just a minute. And who is the class representative in your class? Right? Anyone, please, can you respond? Who is your class representative in your class? Kirti Vasan, anyone? Who is the class representative?
Sarfaraz, sir.
Sarfraz.
Okay, ask, pardon, who is the name?
Sarfraz.
Sarfraz, do one thing. I'll just give my WhatsApp number to you. Can you just create a group? Okay, so that you connect all the guys. I hope 36 guys from our class, this mechatronics, and also you add my number also. I'll just check in the chat box. I'll type it my WhatsApp number. You just WhatsApp us, so that you create a WhatsApp group. So that if any information, so through that also I will inform. Okay, already I gave my number to Kirti Vasan, and I heard that Sarfraz Ismail. So can you pronounce correctly? Sarfraz Muzamil, am I right? Okay. So do one thing, you just create a WhatsApp group, and so that I will also, you connect my number also. If any classes or anything, the advanced classes or anything, the time, everything, I'll just post there, and also I'll post the timetable there also. Okay, so that you will not have any confusion, and together we will learn this semester, and I'm sure soon, very soon, we will meet each other. Till then, take care of your health and take care of your family. Still, Corona is not yet over, and take care of your health and take care of your family members. Okay, so health is much important than other things. So take care of your health, and while roaming here and there, everything, you consider most of your health. So I have taken your attendance, and thank you very much for all your patience until the end of the hour. Okay, maybe due to last 10 minutes due to connectivity. So next time, if anything happens, inform me, and the next class will continue. So this Friday, 7th hour, you will not have class. If you have any classes or anything, I'll inform you. Okay, because 7th hour I have already occupied with other laboratory. Okay, that's why this 2 hours continuously I have taken. Actually, second hour is the optional hour for you, but still I have continued. Okay, and if any future changes, I will inform through your WhatsApp group. Okay, thank you very much. Thank you very much for your patience. Now you can leave. Okay, thank you. Now you can leave. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Okay, ma. Thank you. Thank you.
Thank you, sir.
Thank you.